So I can't see the chat, so I would love to keep this as informal as possible. So if you could let me know if there are any questions as we go along, we can always take a minute and talk through them as we go. But too many things on the screen gets it gets to be a bit much, especially because I'm going to be bouncing around between the web tool. So thank you. All right. Hi, everyone. My name is Amanda Barany, and I'm here presenting the Advanced Epistemic Network Analysis Workshop, Part 1. And I'm here with David Shaffer, who needs no introduction. He'll be taking over for Section 2, Part 2 of the workshop. Let's see. So my section will talk about a worked example, and this is based on dissertation data that I collected and published on last year, involving reflections on the self in a video game community forum space. So I'll talk a little bit about how I align myself theoretically and how that makes sense in terms of using epistemic network analysis. I talk about how I build those models and the different ways we can look at the data to answer different questions and show different patterns in the data. Then we'll examine how to interpret those models. And then that will hopefully flow nicely into David's talk of the nitty-gritty, how to get in depth and understand the models more. So we'll have a small break between our two sections. But like I said, I'd love to have as much as possible, have this be a session where we can play with the data and understand it together and use it as a tool to further discussion. So please feel free to call out questions as you have them. So in general, when we're thinking about learning in the data that I published on in my dissertation, we're shifting away from this idea of learning as something that's passive and static and just accumulating knowledge. And we want to think about it as something that is active, long-term, iterative, and developmental. And so that was sort of the theoretical underpinning of the questions that I'm asking and looking at identity exploration as this trajectory of growth and reflection on the self that's done intentionally over time. So I looked at it and defined it as identity exploration using Dr. Foster's projective reflection framework. But what this means in terms of understanding quantitative ethnographic questions is that the data is organized in terms of each individual as trajectories. And one moment in a person's reflection data, in this case, it'll be forum posts, is meaningfully connected to the forum posts that they made immediately prior. Any reflections they make on the self in one moment is built upon how they reflect on themselves in prior moments. And so that's why the moving stanza window can be a good tool to help understand the connection making that individuals are making about themselves as they're reflecting in places like video game online spaces over time. And the context in which this data was collected is the Kerbal Space Program model rocketry and space exploration game. So this is a single player game where individuals can take on the role of rocket engineers, and they build in a relatively realistic simulated space. They model rockets, they test them, they land them, they can collect data and science on them, and they're embodying different features of that role. So it's a great place to look at how people might be naturalistically taking on different aspects and reflecting on what it's like to be a rocket scientist over time. And we also have some benefits in this game space because there are some robust communities of forums, discussions, wikis, mod communities, all these different online spaces where people connect. And it's important because these are the places where people are reflecting on what they're doing as they play the game and how that shapes whether or not they're exploring rocket engineering roles and how they're reflecting on themselves and learning over time. So we collected data from one of those forum posts where individuals are making these iterative reflections on the self over time. And I collected a sample of some of the most frequent posters on the STEAM community forum. So this is a network of the sample that I collected. And we're going to be looking at a data set of 4 people here. So this is a map of social networks. So the people who are listed here as player 1 and player 2 are the most socially central in this community, meaning that they are connected in meaningful ways to the most other players in the community forum. And this is through friendships and through mutual posting on the community forum. So part of the data set is going to be all of the reflection posts made by player 1 and 2. Then we have lower centrality posters as well in this data set. So these are two people. One of them is connected to this sort of clique of friends that you can see in red, but they are the least socially central in that group. So they're not very connected to friends or through mutual posting. And then there's one person who through the sample is only connected to one other person. And I selected them because they had a lot of data for us to understand what someone who might be disconnected from a social clique might look like. And so I hope that this gives us sort of a framework to understand both the structure of this data and how you could build different models to answer different questions. So here is, you'll see a sample of this same forum post text when David gives his talk in a few minutes. But you can see that this is player one's data organized chronologically by each iterative post that they made. And the moving stanza window is connecting what they said in one moment to what they said in the next moment. Now, we want to think about how we're going to build different units to build models. And one of the things, so I will show, this might be a good time to pull up one of these samples. So this gives us a lot of different ways that you can build models and decide on units to build your model. So you can, let's say you wanted to understand what the two really highly socially central individuals are what kinds of connection making they're making. You can lead with units in terms of their centrality. So we have a unit here that breaks them up in that way. If you wanted, for example, let me move this out of the way, to understand what's all of these different 4 players that we're sampling. Let's say you wanted to understand what is their pattern of reflection making in the first half of all their posts, just as a rough estimate change over time to all of the things that they reflect on in the second half of their posts. You can lead with a unit that breaks it up in that way, post halves. Or let's say you wanted to understand what each of the individuals in this model are saying and what their individual patterns of reflection are looking like. You can lead with a unit that breaks up the data by poster. And there's some other subunits that I use here because it helps us get a little bit of a better grip, an understanding of the structure of this data. So you'll see here an example, day separate. And I'll go back to my slide deck to show you how I created the variable day separate. Basically, to understand the data, I wanted to look at runs of individuals posting. So we're making a lot of different posts back to back to back in a single day. So I created this variable that ticks a number up every time more than a day passes between one time that they make a post and another time that they make a post. And as you'll see, if let's just say for this example with this one, if we show all of the different units, you can see all of the means if they decide to populate. And it helps us get a better grip on what each individual's patterns of posting are. What's nice about making units this way is you can alternate, they're nested, and you can change the order in which they are nested. So to understand, I don't think it's going to load, but give it a try.
You want to try, yeah, refreshing? Yeah,
we'll give it a try. I'll go this way. So you can see these are each of the individual runs of day-long posting that, for example, player one made in the first half of their data set. So this variable post half breaks their data into 2 equal halves. So it doesn't look like it's going to show it right now, but there's quite a few means that help us understand these individual trajectories of posting over time. So to build the conversation, I like to think about defining a conversation as a ribbon of data, of longitudinal data as a ribbon flowing through time. And you need to include variables that tell you where to make cuts in that ribbon so that there are associations that are not drawn across those cuts in the ribbon of time. So the 2 variables that I generated were, the first one is week separate. And basically there I decided that if someone goes an entire week and doesn't make a post to this community forum, that's too long a time for them to be connecting back to what they said in a prior moment. And so it's important to mark those moments because a lot of time sometimes passes between one point and the next in the data set. You know, if a year goes by, what they said that the beginning of that year is not connected to what they said at the end. Another one that I use to try to mark those points across which associations will not be calculated is any time that a participant is changing threads. So these were generated from looking at the data in an in-depth way and understanding how they're posting to the forum spaces. And every time they change threads, they're changing the subject. And so in this data set, that is less illustrative of these runs of the reflection that they're making about themselves over time, given in any one specific moment. So these are the two places that I end up making cuts to this sort of ribbon of longitudinal data across which associations will not be drawn. And then the four codes that we'll use are the cognitive or knowledge-based reflection, so what they know, the interest-based, so what they care about, why this is valuable or important to themselves, their organization, basically their behaviors, how they are structuring their engagement, how they are regulating themselves or others, and then specific reflections on the self, what roles they have, how confident they are in their abilities, any kind of reflection on the self. And this will hopefully dovetail nicely with what David shows in his talk as well. So we can start to examine, now that we've built these models using these different pieces to construct the framework, we can look at to answer different questions. And the most important thing to do once you've generated these models is to understand the goodness of fit of each model. So generally speaking, when we must have a stronger goodness of fit between the visualization. There has to be a goodness of fit between the visualization and the original model. And only when there is a strong goodness of fit can we assume that these interpretations are reliable. So it's always important to check the Pearson and Spearman. And you can see that in some cases, the best goodness of fit that we have is when we are trying to understand the trajectories of the four players. We've got a Pearson of 0.97 and a Spearman of 0.97 and 0.98. So that's pretty good. You can see that in the case of comparing all players from their first half of their data to their second half of the data, the goodness of fit is not quite so good. We've got 0.88, 0.89. You know, this is probably because there are very important differences to be noted across individuals. And when we're just aggregating across the first and second times, we might be missing important things to understand about each individual's unique trajectories. But it's important to start there. So if we wanted to start with a question that is asking what the difference is between individuals who are highly socially central, those who are very interconnected with their peers, and those who are less socially central, we can build this model. And what we see here are a collection of means and then the different constructs that are situated more or less close to each other in the three-dimensional space. And you can see that the high centrality group is close to the center of the model, at least closer to the center than the mean for the low centrality group. And that low centrality group is pulled slightly to the right into the, I would say, the two right-hand quadrants. And this is a means rotation, which is maximizing the difference between these two groups for statistical comparison and visual comparison. And so you can see when you build out this model that the strongest association for the lower centrality, the less socially central individuals in the game space, is this connection here between their organizational practices and their knowledge. Whereas if you look at the higher centrality group, that relationship is still there, but it is not quite as strong. And they've got a little bit more strong connections to their sense of self and the reflections they're making on how they see themselves in this space. The easiest way to look at that is to make a difference model where you're subtracting the weights of one from the other. And here that is particularly notable that for the lower centrality group, there's a stronger connection between their organization and knowledge. So what does that mean in terms of understanding these player groups? When we looked at the data to close the interpretive loop and trying to understand what we see about these players, we can see that the two less socially central individuals are engaging in a lot of help-seeking behaviors, or in some cases, they're trying to shape this space to meet their own needs. So we're seeing a lot of codes and a lot of examples where players are saying, I'm new here and I know this about how to make a rocket, but I don't know how to make a post to this community forum. I need help. or I know a lot about how to make a model rocket, but I don't know how to use this particular in-game mod that's going to reach the goal that I have set for myself. So there's a lot of really concrete examples of individuals talking about how to engage in this online social community. And you're not seeing that as strongly in the higher centrality group, because potentially oftentimes they are engaging as leaders, social leaders in this space. So they have a lot of friends and they spend a lot of time talking about themselves as engineers, as artists, as creators of rockets. And they're using these regulatory practices. They're talking about the different things they're doing in the space, and they're connecting it to what they know and what they find valuable about that. But it's less of this emphasis on how to engage in this space and how to be structured and meet their goals. Because in some cases, they're already relatively successful at meeting those goals. And that lines up with what we're seeing in terms of their reflective data. They're spending some more time talking about how they see themselves, but there's a limitation in terms of the community forum that they don't really ask people to reflect on the self. The kinds of prompts that are in the discussion forum that they're asking people to talk about are things like, what did you do in Kerbal Space Program, this video game? What did you do today? And that's going to naturally encourage people to talk more about their behaviors, about their organizational patterns, and it's going to prompt them to talk more about their knowledge than it is going to prompt them to talk about their sense of self. And so it's important also to consider the design of a space when you're understanding the kinds of reflections, or in this case, the learning and the reflections on the self that are happening here. It isn't just that people don't want to talk about the self, but also what design features of the space are encouraging or discouraging different kinds of reflection. It's also important to note that there are differences between the individual players. So this is a singular value decomposition. And so it's about comparing each of these 4 individual units and less about maximizing the variance across 2 groups. But you can see that player 4 here, who, if you remember from the social network, was actually socially disconnected from this group, is also the furthest away in terms of their positionality in the 3-dimensional space. And you can see that their knowledge and their connections to organization are particularly strong. This person's trying to really change how the forum posts get made, is asking a lot of questions, is asking for a lot of help. And so this person is very distinct from the other 3 players who are connected to the social clique. So there's interesting to see some alignment there. A final thing that I want to point out is the situation of the 4 constructs in relation to each other. So you can see in each of these models, regardless of which units we lead with, we're seeing the knowledge construct is situated closer to the organization construct than either of those are situated near the interest or the self construct. And so that could be because they are more tightly interconnected. And that is brought to bear in terms of understanding the data. So oftentimes when people are talking about their knowledge and what they know, they're also talking about how they're going to use it, how that affects what they do in the space. And so they might also be more thematically interconnected than something that's a little bit more distinct, like what they find interesting about in playing Kerbal Space Program and making rockets, or how do they see themselves in the space. So that is also really helpful for us in terms of understanding these models and the outcomes of this data. So let me find my slide deck. Here we go. So ultimately, this is just synthesizing some of the main points that I found in terms of setting up this data set that hopefully will encourage some of us to explore and ask more questions about it and dovetail nicely into David's more in-depth descriptions of how models are formed and how we can understand them. But also ultimately, there is a connection, at least in terms of understanding the data and closing the interpretive loop in terms of what players are saying, in terms of connections between their situatedness in the social network and how they're connected socially to their peers, and how they are their patterns of connection making over time in the epistemic networks. So there's something there that I would like to explore more in research, that player 4 is so distinct both in terms of their patterns and in terms of how they're situated in the social network. And you can see that some of the players enacted more balanced processes of reflection, or some groups were more balanced in connecting all 4 of the different aspects of self, and some were less connected, but all of these are valid. It's a naturalistic setting where all kinds of reflection are accepted and encouraged. So there is no perfect way to engage in reflection. However, if your goal as an educator, for example, would be to encourage balanced reflection, this could be a useful tool for seeing, okay, this person who's playing a game is connecting to all of the things that we want them to connect, and this person might need other scaffolding. Or it also prompts questions about what does the affordances of the design of a space. So what is a community forum that's asking people to reflect on what they do and not opposed to, and not who they are? What does that do in terms of shaping people's reflections and ultimate learning processes? So these are all things that examining this data and building these models helped us to understand. And with that, I welcome any questions, and we can definitely play around with these models more if that is of interest to anyone. If anyone has a burning question and wants to reorganize the units, then it's more than welcome. Let me find the chat. I'm going to stop sharing for a moment so I can make sure I see it.
Yeah, there isn't anything in the chat, but maybe we could just take a minute and thank Amanda for a great introduction. Mamta looked like she had her hands up a moment ago. So Mamta, did you have a question you wanted to start out with?
Sure. Thank you, Amanda. Always pleasure to hear you talk. Could you speak a little bit about how I know you said you went through a detailed process, understanding what your participants were doing in the community space. How did you sort of determine who were the high centrality and low centrality? Like, if you have an image of what that data looks like?
I do. Yeah, so it was an iterative sampling process. Give me a moment to open my dissertation PowerPoint. Here we go. Okay. So it's a several-step process. So in the community forum, or the community space, where everyone who plays Kerbal Space Program on Steam, which is an online platform for hosting video games, there are 230,000 registered users, which means that the criteria for inclusion there is that you've purchased Kerbal Space Program. That's it. You're automatically opted into the online community space if you bought the game. Now, whether or not you engage in that space is different. So we want to drill down into people who are actively using the community forum on Steam, people who are posting and connecting with each other and making friendships. And these are bidirectional friendships, similar to like a friendship on Facebook would be. So if you friend someone, they accept you, then that is a connection that is built. So the first step in terms of sampling from that overarching 230,000 users was finding all forum posts made on the community space, on the platform. And then only sampling in participants who've made at least one post to the community forum. And that was an N of 2,135 individuals. And then that's still really big. And also that might include people who aren't particularly socially interconnected. And I was really interested in looking at what is the relationship between individuals' connections to friends who play Kerbal Space Program and the ways that they're engaging with the forum space to reflect on the self. And so then we subset that sample of 2,135 to look at a sample of 78 individuals. And that was the people who made at least one comment to the community forum, in addition to one of their friends or more also having made at least one comment to the community forum. And that's how there's a network of particularly interconnected individuals, this clique of friends. So all of these people have at least one friend, but in this case, many friends who post to this forum. And oftentimes this is people who post regularly. And it's not a particularly dense clique, but still. And then that's why we have these formulations of these dyads and triads as well. So in this case, it's someone who posts maybe once, maybe many times to the community forum, and they have only one, or in some cases, two friends who have also done the same. And so that's why the sampling involves many dyads and triads. And I thought it was important to understand, is there a difference between someone who is in a dyad, who is maybe just one friend who's engaged in Kerbal Space Program, versus someone at different, in different situations, social situations, who are part of that clique? And I mean, this is a relatively small sample, but I would argue that at least for these cases, yes.
Thanks, that's very helpful.
Mm-hmm.
So Amanda, while people are mulling over what you presented, I have a, no, it's not exactly, well, it's a question, I guess. So there's always something in presentations, especially, that's feels a little bit like magic, in the sense that somebody, you showed some sample data. Obviously, this is not a critique, because you weren't trying to present the paper and convince us that the paper was correct. You didn't walk through a qualitative example and so on. But even if somebody does walk through a qualitative example, they sort of show the qualitative example, then boom, these dots appear on a page, and then there's a bunch of lines, and then they say, okay, so these things look like there's a thick line here, and here's what that means. And obviously, in the next segment, I mean, I can explain why the math works that way. Like that's one part of the magic.
Mm-hmm.
But there's another part of the magic, which is how you actually think about the sense making. And I'm wondering if maybe you could just unpack that for us a little bit. So, in this case, how much qualitative analysis went in first? When the web thing came up, how are you thinking about it? How do you think about digging into it?
Right.
Like, does that make sense as a
it does.
query?
Yeah. And I think what I tried to do, and what our team of Mamta, you were definitely a part of that team. What we try to do is base every decision in terms of how to build the model and how to understand the data qualitatively, and using these epistemic networks. We try to always go back to the data and how it's structured, what we understand from it. So things like generating these variables in terms of where to cut the conversation so that associations are not drawn across them, was involving us going back in and reading the actual transcripts of these forum posts and what people are saying, to say, okay, that makes sense. More often than not, people are not drawing associations across these inflection points. So in every step of the way, in terms of building this model, it's always about what is the data telling us, how is it put together, and what can we understand from that first. But I also think, to your point, it's really important to not just have a model and then retrofit your qualitative findings to whatever the model says. And so one of the steps that I did when I was developing my dissertation and understanding this research was go through these data sets and write up qualitative noticings. I did sort of a memoing process that eventually developed into case studies of my understanding of what do I see when, player one, who you'll talk about a lot actually, is writing about the processes they're enacting. How is he talking about his interest? What do I see? What examples support my assumptions? And reflecting on any biases I might have is an important piece of that as well. So it is completely connected to what we understand qualitatively about the data. Then and only then, once I've generated those memos and have at least an outline of what a case study would say, do I look at these models and see what the alignment might be. There is sometimes, and oftentimes there's a lot of alignment. So if, I see that player one, who was, up in the upper left quadrant, which means that they had the most connections to how they see themselves. So sometimes I see that. I did see that in that case, that person reflected a lot on themselves, but sometimes not. And then that involves going back to the data to understand, is the difference between what the model is showing me and what I thought I saw thematically, is that from my misunderstanding of the data? Is that from something in terms of not structuring the network in the way that it should be to fairly represent players? Because it's important to interrogate that as well. What I'll say really quickly is that, what we found in terms of one of the players is that they had a tendency to bounce back and forth between changing threads all the time. So it really limited the ability of the model to give us a clear picture of what they're doing. Their confidence interval, the box around their mean, is huge because their data set's being cut up too much. So if you really want to understand their data, it might be useful to cut the conversation up in a different way. For this instance, for example, we kept it consistent, but that's something important in terms of connecting what you do thematically to the model and how it's made.
So if it sounds to me like what you're saying is the demystification actually comes from the fact that you already have in your head an understanding of what was going on. And when you're looking at the dots and you're looking at the networks, those are pictures of something that you have already seen from another point of view.
Yes.
Is that about fair? And
absolutely.
Are you starting with when you do that, are you starting with the networks? Or are you starting with the plotted points? Like when you've done these case studies, you feel like you understand these data and these people, right?
Mm-hmm.
And then you put them in the model, having made all these choices, throughout.
Mm-hmm.
I would say that sounds more like closing the interpretive loops rather than the interpretive loop. But in any case, right? You've cycled back through the data, you've constructed the model, and then you push go, and we all know that the first thing that shows up is a bunch of points, right? What do you actually do next? Like, what does it look like when you first confront one of these models? What do you actually do to make sense of it?
Right. That is a great question. And it depends on the question. So I have 3 examples here just because I thought that might be interesting to further discussion. We have we have research questions. So the research question in for this model would be, what are the differences in patterns of reflection making across these 4 players? The research question here might be something like, what are the differences between highly socially central individuals and their patterns of connection making and less socially central individuals and their patterns of connection making? So I generally start, usually this is how a model, I hope it doesn't get mad at me if I show all of these. Yeah, okay.
And then you're going to close the plot, right?
Yep, that's right. Yeah, so this is what you would get traditionally first. So I like to do first an examination of the central means. So this would be the mean for the high centrality and the mean for the low centrality. I like to look at their confidence intervals to see if they are overlapping, because that will tell us if they are statistically different. And I tend to use non-parametric tests to determine that, just because this data has no reasonable expectation of normality. But it also is important to note that in some of these questions, that is not an important variable. So it makes sense here that players 1, 2, 3, and 4 could be, distinct. They could be statistically significantly different, or they might not be, and that's fine and valid. So it may or may not be useful to start by looking at confidence intervals. But here, for a means rotation, you're comparing 2 groups. It's interesting to see, are they overlapping or not? And this is all after I've checked for goodness of fit, of course. It's also interesting to look at the positionality of the means for each of the units you identify, and also where they cluster. So you can see that, the high social centrality mean here is closer to the center of the model, but it is slightly to the left towards, the self and interest. And you can see that some of these units, their means, are probably responsible for part of that pole. And then you can also look at the clustering of the lower centrality means, and they're actually pretty widespread. But there's some outliers definitely pulled way over towards the organization and knowledge connection. And so it's important. So I look at that to try to understand what's happening. Then, just for visual clarity, I'll usually hide them. And what I like to do then is a difference model. And it's important when you're looking at a difference model, I find, to always be going back to what the original models that you're comparing looks like, because then you're accounting for any times that two particularly strong patterns of connection across two constructs are canceling out. So, for example, you can see in this difference model, knowledge and interest is that connection is relatively strong for both the low centrality and the high centrality individuals, but in the difference model, it cancels out and you can't see it. So this gives you a rough idea of what are some of the, what it maximizes the difference across these two groups for quick understanding of that. But then it's also important to look at the low centrality model, where you can see this organization knowledge connection is really driving the pull of that mean towards the right. And then this model for the higher centrality individuals, and you can see the relatively stronger patterns of connection between knowledge, organization, and interest. That triad is really driving their discourse. You can always mouse over and look at the numerical strength if that is useful to you as well.
So I'm struck as you're talking by the sense in which, and I hope you'll take this the right way, it sounds almost like you have spider's eyes. So spiders have eyes that have like multiple lenses, and so they're sort of constantly looking at a scene from multiple perspectives. Mm-hmm. And in a way, it seems like you're holding in your head a kind of synthesis across the original qualitative story as you understood it and what makes sense. Mm-hmm. The means and confidence intervals, mm-hmm. the spread of the points around the means and confidence intervals.
Yes.
The individual networks of those means, mm-hmm. the difference network between the means in a model like this.
Yeah.
And then also this notion that something to the left or to the right is because the connections are stronger left and right. And mm-hmm. you're kind of it's almost like you're holding all those perspectives at once and maybe tacking back and forth between them. Can you tell us a little bit? First of all, is that an apt description? And if it is, like, how do you keep it straight as you tack back and forth? Because mm-hmm. you've done this a lot. I assume there's some people on the call, on the workshop, who haven't necessarily done it as much as you. That's why they're in the workshop. How do you? It doesn't sound like it's just you do this, then you do this, then you do this. It's this sort of negotiation of this, spider-like space. Can you just say a little bit about whether I'm right, and if so, how it is that you go about that?
I think
thinking about that.
It puts to words a lot of, I never really interrogated how I would define what I do in that way, but it makes a lot of sense to me, that sort of analogy. I really loved Charlotte's Web, so I also don't mind that comparison whatsoever. But I think one of the things that is important to me is it's not about any one model, because once you have that, it's about understanding it from different ways. And I don't know if triangulation is exactly the right word, but it's this idea that your data can be visualized and interrogated in different ways, and that those different ways all have something to say about this data, this space, the phenomenon that you're looking for. So I oftentimes, if my question was, what is the difference between high centrality and low centrality individuals? You might just go in and just make, lead with units, social centrality. And then you say, okay, well, does that line up with what I thought? Yes, no, meh. And then you could stop there. But I think that loses some really important nuance that you can learn from exploring and interrogating your data using different configurations. So when I made the model that is looking and comparing all four players to each other, that showed me some really interesting information about how the two people who are identified as less socially central are actually relatively distinct in terms of their patterning. And so just making a model that maximizes the difference across high and low centrality, you might be missing some understanding of this data. And it may or may not line up with what you did qualitatively up front, but coming at it from these different angles and reconfiguring the data, asking different questions, challenging what you think you understand, both in terms of the visualizations and your qualitative your qualitative assumptions, I think that's all really important. So I think it's less about one specific question and more about the complexity of a data set. I don't know if that answers your question, but.
Oh, that's very helpful. Thank you. I see Hanal has her hand up, so I don't know whether Hanal, you want to jump in.
Sure. Like, first of all, thank you so much for giving a nice talk, Amanda. It's nice to see you here. My question is about the model itself.
Mm-hmm.
So I see that your model is a like parsimonious model, I can say, because you have only 4 codes in your model instead of like one common issue we can have in using ENA is overfitting the model with too many codes.
Absolutely.
Yeah, and I'm wondering what kind of, like, have you had any iteration process to trim them down, or do you think that did you fix this model because it is a best fitted model that you can sense of by having a thorough understanding of your data?
Yes, that is a great question and something that I've pondered over. So thanks for asking that. So these 4 constructs that are sort of the big umbrella constructs of identity. So if you had to distill down everything that someone might be doing into 4 big categories, those might be the ones you would choose. And of course, that's always up for debate, depending on your theoretical positioning, what literature you tend to synthesize, what models you use, all of that affects what codes you generate. I use those 4 codes for the purpose of illustration here. But if I can get I want to show you what we are also doing, and this is in collaboration with David and Yeyu Wang. So there is a model for projective reflection that has quite a few more codes. Will this load? And so those are intended to align with lots of different facets of reflection on knowledge, different facets of interest and valuing of a topic, different facets of your organization, your regulation, your processes of engagement, and different facets of your reflection on the self. And so that's actually a 20 code model. And those generally tend to align up under the 4 buckets. So knowledge, interest, organization, and self. But we've been playing around and testing Yeyu's parsimonious, David, you might have to help me with the acronym, or Yeyu if you're here, parsimonious reduction. It's a technique to help you identify which of the constructs you can drop from a model while still retaining the fundamental meaning of your data set. So we know that 4 is limited and it's sort of our big picture, but we are testing out what it looks like when we've got here. Let me see if I can get it to load. I would love to talk more about this process. This is a different project we're engaging with.
It's interesting that you raised that, Amanda, because so what I don't want to speak for Yeyu, but in the sort of short version is that what the technique does is it looks at all the nodes and it finds a node that basically is really small, isn't doing very much, and it tries taking it out to see whether or not the whole network reconfigures. And this is what people tend to do, or at least we've observed people do by hand, right? They look at the model and they say, oh, this code doesn't seem to be doing very much. And so this is just a way of sort of mathematically getting a handle on which codes you could remove before things change too much. So it's sort of, yeah, there's the 20 code model, right? But that depends. So that depends on a few things, right? One of them is it depends on your initial big model being something that you believe is correct. There's no point in preserving the meaning in something that wasn't meaningful to begin with.
Right.
Then the other thing is there are 3 criteria, right, that the model uses, or sorry, that the system uses to preserve the meaning. And Yeyu, maybe you could just quickly say what those 3 things are, because we're talking about interpretation. So what does it mean to have a model mean the same thing? The PRIA is basically making a claim about what it would mean for a model to mean the same thing.
Yeah. So in order to answer this question, we first need to operationalize about what do we mean like two models are similar. So we define or operationalize that into 3 different criteria. The first one is the dimension of the interpretation of the dimension based on the node position. So we're assuming that when taking out some nodes, the remaining nodes has a similar relative position in the space compared to the original nodes in the space. So we make correlation based on that node position. So that's the first criteria. The second one is the interpretation of the units. So we have ENA score as a summary statistics of each unit. And we also correlate the reduced set with the original set to see whether the interpretation of the units changed. And the third one is we need to maintain a goodness of fit of the model in order to see or interpretation based on the model, based on the dimension is valid to do so. So those are the 3 criteria that we operationalized.
Yeah, and the third criteria we'll talk a little bit more about maybe, but so goodness of fit is you basically have these 2 representations, right? You have the network graph and you have the points, and goodness of fit is just telling you how closely aligned those 2 representations are. But the other 2 criteria that you just mentioned are both spatial, right? It both has to do with where things are in the diagram, and I guess part of what is kind of lurking behind what Amanda was saying as she was walking us through all these different permutations is that where things are located relative to one another is sort of a key to understanding how to make meaning out of these representations. Amanda, is that a sort of a fair summary of what you see going on as you're kind of working your way through these?
Absolutely, I would say so. I think there's some alignment there, both thematically and also just the relationships. It makes sense that they would be positioned near each other in terms of understanding how we define them and how they manifest in the data set that you're using. And it can differ by context, so yeah.
I know I see you put your hand back up. Did you want to follow up, or do you just leave the hand up?
Yeah, I just want a quick follow if time allows. I can see the criteria has applied here, but as you can see here, all the nodes are kind of spread around the x-axis and y-axis for different direction. But when we actually use the bucket, the parsimonious model, I was able to recall that the knowledge code and the organization code very closely located.
Oh no, I think we've lost you. No.
I
right the axis in the about now. Oh, geez. Okay.
I think I may know what you're asking, but sorry, go ahead.
Yeah. So yeah, my question is basically what happened in a parsimonious model? Why those 2 different buckets located too closely in a parsimonious model?
Right. So what we see in terms of so if we're thinking about the data, if we're thinking about the theory in terms of these 4 general processes, these cognitive knowledge-based processes, these interest processes, these organizational processes, and these descriptions of self, if we're looking at it from that lens, you can see that in the data, people tend to talk about what they know, and then they also tend to they tend to connect to what they are doing with what they know, which is an organizational process. So there's a lot of connection making happening, but then also thematically there is some relationship there because it's foundational knowledge, like I know this, and then there's also this meta piece. I know how to use this thing that I know. So there is a thematic alignment there. So when you change the framing of the theory to, instead of focus on these overarching buckets of processes or to these very specific individual actions, then you can see what might be driving different relationships in this model. So organization would be here, self-organization would be goal setting and offering help. So those are 2 organizational processes. that these players may be interacting in this game space. And then the foundational ones that are here are their knowledge of model rocketry, which is K foundational, their epistemic literacy, which is knowledge of the forum and how to engage in that space, and their interpersonal skill, which is knowledge of how to successfully communicate with peers. And you can see that breaking them out this way, you can see some that still are connected thematically, like epistemic. These different kinds of knowledge are interconnected, but breaking out the different organizational processes, you can really see which ones start to end up being thematically distinct. So goal setting is actually in this model relatively far away from offering help. Now they are still different. They're still, you know, the lens, the frame that we're using here is different. So it makes sense that they would be distinct. But if you're going in asking codes, using codes that are bigger buckets, you're going to get, it's a different frame. I don't know if that makes sense.
One thing I would say is, right, if you were to use the AU's technique on this model, you wouldn't actually get the four bucket model that you first showed, right? They don't actually have the same meaning.
That's
and right. They don't have the same meaning because one of them is, as you're saying, it's sort of looking at it from a different grain size.
Yeah, it's bird's eye view versus really starting to dig into the very specific processes we are seeing. Yeah.
So Lupita, I see you have your hand up. I was going to suggest that we take maybe a 5-minute break. Is it a short question or a longer question? If it's a longer question, maybe we should cover it after the break.
Yeah, well, I'll pose my question and then y'all can decide whether or not
it's short or long.
Fantastic.
Because it might be quicker and it might not. But it is a follow-up from the previous question. And hi, Amanda, thank you for a wonderful presentation. So I wanted to see if you could speak to the interpretation of the axes, especially in the parsimonious model. There's a lot more variance being explained by the plot in the two axes versus this one. There's less of the variance being explained, even though you have sort of a more explicit coding, right? That allows you to sort of be more descriptive about what is going on. So two questions. One, did you do an interpretation of the axes in either of those models, and how would you interpret those axes? And second, if you did, then how do you explain the variance that is being explained by one model and the other?
That is a great question. That is not a short question. Let's do this. Lupita, if you don't mind, I think actually that will be a good question to jump into after we've dug into the math a little bit more. So would you be willing to ask it again a little bit later?
Yes, that sounds great.
Okay, sounds good. Great. Well, why don't we take a 5-minute break until the top of the hour? I know that there's some people for whom this time zone is terrible, and if you wind up not joining us at the top of the hour, we will certainly understand. It's being recorded, so you'll be able to get at it later, and we'll see everybody back in 5 minutes or so.
Thank you, everyone. Please reach out if you want to chat more.
Well, hi, folks. Welcome back. I can't actually tell whether any of you are back because there's like 5 people who have their camera on, but that's fine. I'm just going to assume you're back. So on the assumption that you're back, let me go ahead and I'm going to share my screen in just a moment. I'm going to try and walk through some of the math behind what it was that we were, that Amanda was just showing us and that we were just talking about. And then hopefully there'll be time for questions and more discussion. See if I can do this so that everything shows up in the right place.
The eternal struggle.
Yeah, the struggle is real. That is not in the right place. Let me try it the other way around. Sorry about this. I guess I should have thought of this in the break. There we go. Okay. That is now showing up in the right place. And now I should be able to share my screen. And all right, so can you guys see the word rotation? Excellent. One of the things that we have to understand in order to get what's going on with ENA is the notion of a rotation, just, you know, twisting something about. And here's a way of thinking about it, right? If we have a set of points, we all know that the points are really important in ENA. If we have a set of points, a rotation, and let's say those points have a couple of means, rotation is just a way of kind of turning the whole, everything that we see on the graph around the center, around the origin. And that's easy to see visually. The way that happens mathematically is with matrix multiplication. And I promise this is about as deep into matrix multiplication as we're going to get. But so essentially each of those points, right, can be represented by a pair of numbers, the x coordinate and the y coordinate. So depending on where the points are, they're going to have different coordinates. Some of those coordinates will be negative if the points are further down. And what we're going to do to rotate the points is to multiply two matrices together. The first one is the matrix of the data. The second one is a rotation matrix. So rotation matrix just has a bunch of numbers in it. In this case, that's the rotation matrix for a 45-degree rotation. So if we do this multiplication, it has the effect of moving those points around 45 degrees. And what it means to move the points 45 degrees is we just get another set of numbers which represent the new points. So the one on the long tall matrix on the left is where the points started, and the long tall matrix on the right is where the points wound up. And the matrix in the middle is the way in which it got multiplied. So it's just sort of relatively easy to grok in 2 dimensions, right? Each point has 2 dimensions, you rotate it, that all makes sense. Problem is that in ENA, we're dealing with a multidimensional space. So this is sort of the third concept that we have to get here. And the idea of a multidimensional space sounds scary, but it's just kind of an analog of what we're doing in 2 dimensions. So to make a space 3-dimensional, we just add another column to the matrix and we add another dimension in the space. And then all the points get a value in the 3rd dimension and we're set. We can add a 4th dimension if we want, and we could add a 5th and a 6th and a 7th. The problem is that thinking about these higher dimensional spaces is really hard. Most people are not very good at it. So what we do in ENA is we take a higher dimensional space, we multiply it by a rotation matrix to put it into a lower dimensional space, to put it into 2 dimensions so that we can visualize what's going on, right? And that's where the points in ENA come from. Literally, there are points in a high dimensional space. We're doing a rotation, which just means we're multiplying by a matrix. To be fair, there's also some sliding around of the space that goes on, but that's the important part is that we're you guys are seeing these slides, right? Okay, there's just something weird going on my monitor. So the question then becomes, well, how do we choose a rotation? What do we want to do with these points to get them into this more visual space? We're basically just choosing a matrix. So one way of thinking about that is imagine that the points, right, are actually a bunch of people sitting around a conference table. And what we're doing when we make a rotation is we're taking a 2-dimensional picture of where they're sitting. So the question is, well, what angle could I take the picture from that would give me the most information about those people, right? So I could tip it up so that the camera is perfectly aligned with the plane of the table. And then I could see where people were positioned right and left, and I could see maybe who was taller and who was shorter. And I could think about that as having a pair of axes through it, so I could measure how close and high and low people were. I could flip it around and look from the end of the table. That would certainly get me a good grouping of people, but I wouldn't be able to distinguish much about people between the groups. And then the usual best solution is to look down from the top. If I take that picture, now I get kind of the most information about where everybody is sitting. I lose whether people are tall or short, but I get where they're sitting kind of, you know, along the long axis and along the narrow axis of the table. And there are a few different techniques to do this. The one that ENA uses is something called the singular value decomposition. And we don't need to go into the math of what that's doing, but basically that's what it's doing, is it's producing a view where you get the most information about where the points were in the original high dimensional space. The alternative, which Amanda actually showed us both of these views, the alternative is a means rotation. And all that a means rotation is doing is literally finding the two means in the space and finding the line that goes through them and making that the x-axis. And then for the y-axis, it just tries to figure out how to get the most information. It does an SVD actually to get the singular value decomposition to get the rest of the space. Right? And that is where we get this from. We have a bunch of points in the high dimensional space. And we do a rotation. We can choose a couple different rotations, and that's what positions these points in these pretty patterns. Of course, that raises the question, well, what do you mean there are points in a high dimensional space and how did they get there in the first place? So let's talk a little bit about ENA matrices. So this is the piece of the data that Amanda showed, right? And as we all know, we don't actually look at this data in ENA, we look at the coded data. And what ENA does with a moving window is it takes a little window, slides it along the data. And at each point in the window, what we're looking for is to see whether the last line in the window has codes that are connected to the lines up above. And we just keep sliding along them, you know, checking for whether the codes are connected until, lo and behold, we find a window where they're connected. And what we do then, so here we have a connection between knowledge and interest. What we do is we represent each unit in the data. In Amanda's data, it's a player at a particular time. So that's why this is player 1 T6, right? There's a connection between knowledge and interest. And we literally have just a little table here. And we mark a 1 where their knowledge and interest intersect. And as the window slides along, maybe we see a connection between knowledge and self. Maybe we see another window with a connection between knowledge and self, and another. And then we see a window where there are connections between interest and organization and self. And then there are more connections between organization and self, and even more connection as the thing goes along, right? We're literally just, with each window, we're just adding to this matrix. And notice that we're not putting anything in the bottom part of the matrix because the matrix is symmetric, at least in regular ENA, and directed ENA it isn't, but that's a different talk, right? So what we're going to do with these matrices in order to be able to deal with the fact that we have lots and lots of units is we're going to change the matrices into vectors. And what I mean by that literally is we're going to take this matrix and we're going to throw away the parts that we didn't use anyway. And then we're going to change the headings there. So now instead of knowledge, interest, organization, self, we have knowledge and interest, knowledge and organization, knowledge and self. And then we'll take the next row of the matrix, right? Now we don't need the header on the first row, right? Now we take the next row and we're going to copy the 1 and the 2 up and put the label, make the labels correct. And then we can get rid of that part of the matrix. And now we're going to take the last little bit, which is self and organization, and we put that up there. And now we have this player represented, their matrix represented by a string of numbers. And all the string of numbers is telling us is how many windows were these things connected. But of course, we don't just have one unit or one player, right? We have a whole bunch of players or times or whatever else it is. And that, what you're looking at right there, that's the high dimensional space. We're not looking at it that way, but that's the high dimensional space. That tells us for each of these pairs of codes, how many times each player connected. And we can see some things by looking at the matrix, right? We could see that, for example, nobody here connected knowledge and organization. Or we can see that players 1 and 2 connected knowledge and self a lot, and players 3 and 4 didn't. Or that for both interest in organization and interest in self, players 3 and 4 connected a lot, and players 1 and 2 connected a little bit, and so on, for all of these different dimensions. And it'd be perfectly fine to look at the data that way. It's just, oh, right, when we plot high dimensional matrices, when we try and deal with high dimensional matrices, our brains explode. So we're going to try and figure out a way to plot those vectors. That's that high dimensional space, right? And so to plot those vectors, we are going to choose a rotation, which means if these are our vectors, there's only 4 dimensions here, or there would be 6 otherwise. We're going to rotate by some rotation matrix. That's going to produce some set of points, just as we were talking about earlier. And that's where those points come from. Right? So this, I think, actually sort of answers Lupita's question, or potentially answers Lupita's question, right? SVD is trying to maximize the variance. That is all the ways in which the points are different, right? If I have 4 codes, as we just saw, I have 6 dimensions, right? So there's 6 dimensions worth of variance being represented on 2 dimensions now. If I have 30 codes, then I've got, what is it? 29 times 15 is 435 or something, dimensions being represented in 2 dimensions. So the ability of those 2 dimensions to pick up the variance over 435 it's harder to do that than to pick up the variance of 6 dimensions with 2 dimensions. That's my guess anyway. Obviously, I haven't looked at the data specifically. Now, what I just told you is actually not quite true. This is not exactly the way where those points come from, because there's one other step that we do, and that's called normalization. And so here's a way of getting a sense of the problem. So if these are 4 different players, right, and we sum up the values of their rows, we see that the numbers aren't the same. And what that means, right, is that one of these players has their point a lot further away from the origin. The distance is longer. And so we have a problem trying to figure out which of these players are similar to one another. Here's a way of thinking about it, right? If I have these vectors, are the blue vectors more similar, or are the red vectors more similar? If I say the blue vectors are more similar, it's because the distance from one player to the other in the high dimensional space is longer. If I want to say the red vectors are more similar, well, it's because the players are sort of going in the same direction, if you will, right? They have the same angle, or a similar angle, I guess I should say. The thing to keep in mind, right, is I could take any one of these vectors and I can just, make it longer or shorter. It's basically the same vector, just the length is different. And if I make the length of the vectors more similar, then the 2 red vectors are the same or similar, right? Why might I want to do that? Well, if somebody talks more than someone else does, right, I have more data about that person, but that doesn't mean that they're necessarily, other than they're talking more, they might be exactly the same as somebody else. There's a thought experiment. Imagine that instead of this being a 2-hour workshop, right, it was a 12-hour workshop, but all that Amanda and I did was say the same thing 6 times in a row, right? There wouldn't be that much more information comparing that workshop to the original workshop, other than that you would all be bored and stop after presumably after the first time. So what we do is we normalize. That is, we make all the vectors the same length, which is not as exciting as it sounds. We just divide them through by their length. So we get a set of numbers that looks a little bit different. They're actually all between 0 and 1, because 1 is the maximum length that we allow if we divide by the length. This has a very strange sort of side effect, which is probably worth knowing something about, right? And that is, if I look at these 2 vectors, the 2 vectors in red, notice that the top one has a smaller number in the 4th column than the bottom one does. It's a 2 versus a 5. Over here, they're the same vectors, they've just been divided by their length. It's the other way around. The top one is longer, which seems weird, right? The top person made the whatever that fourth connection is fewer times, but their number is bigger. And you can see why here, right? So here in the original, the green number is bigger than the red number. Why? Because the number's bigger, vector's longer. When I look in the shorter, when the two are shorter, the number isn't longer anymore. That original dimension isn't longer because I've shortened the whole vector. And what's happening is these numbers are all relative strengths. It's how strong did I talk about connection 4 relative to connection 3 or 2 or 1. That's what the normalization does. So it's giving me kind of the shape of how I'm talking, not the amount. In any case, these numbers are actually the ones that get multiplied by a rotation matrix in order to produce those points. Okay, so now we've explained the points, and mostly I'm not telling you a lie. As I said, there's a couple of small pieces that probably don't change anything that we've left out. But so now the question is, well, what about those network graphs? Well, okay, so the network graphs, we have these points, right? And the network graphs are just using the same data that we made the points out of and turning them into a network graph where each row of data, each player, right, gets their own network graph. And remember that those numbers represent the strength of connection along each pair of codes. So what that translates to is the thickness of all of these lines, right? Smaller number, smaller, thinner line, bigger number, thicker line. So that 0.8 translates to a line that has a thickness. The thickness is not actually 0.8 because they're measured on different scales, but it's twice as thick as a line with a thickness of 0.4. Okay, you might say, well, great. So that's the line thickness, but why are the codes placed where they're placed? Because that's sort of magic, isn't it? Well, so there's one other thing we have to explain, which is co-registration. And co-registration is just the fact that we have this picture and we have this picture, and what we want is this picture. That is, we want them to be related, those two different pictures to be related to one another. And so to understand where that comes from, we need one more math concept called a weighted average. So here's the idea of a weighted average, right? Imagine I had like a teeter-totter, a little seesaw, and I put something with a weight of 1 on each side. It would stay balanced, right? If I moved one of those blocks towards the center, the teeter-totter would slip. But in order to keep it in balance, I'd have to put 2 blocks over on the left-hand side, or 1 block with a value of 2. If I put the value of 2 at the end, it won't be balanced again. I could balance it by putting on more blocks, or I could move the center of the teeter-totter to get it to balance again. If I put on more weight, well, the balance will be off. I can move the center again, and basically the way I calculate that center is called a weighted average. And so if we imagine that this is in a coordinate plane, then the location of those weights would be at -3 in this example, and 2 and 3. If I take the -3 and multiply it by 2, I take the other 2 and multiply them together and add them all up, divide by the number of blocks I have, and I get -1/3, which is where the center is. So that's a weighted average, which is also called the centroid. So the centroid is the spot where something balances. I can do the centroid on the y-axis as well, right? And essentially, right, I can think about any network as having a centroid. So if I have knowledge and interest connected to one another and they both have a strength of 1, the centroid is going to be over here. If I add the self and I still have them all even, then the centroid will be in the center of the triangle. If I make knowledge bigger, then the centroid will move towards where knowledge is. It's where I'll have to balance it, right? If I make interest bigger, the centroid will move up towards interest. Basically what's going on is now every network has 2 things, well, 3 things. It has its network, it has its centroid, and it has a plotted point, which we got from normalizing the vectors and multiplying by a matrix to get our rotation. And now all we're going to do is move the nodes so that the centroid and the plotted point line up. And that's where we're going to put the nodes. Well, hang on a second. There's actually lots of plotted points. And there are lots of networks, so there are lots of centroids. So for each of these centroids, what we want is if the network is down here, right, then its plotted point is down there. And if its centroid is here, then we want its plotted point to be up there. And if its centroid is here, we want its plotted point to be there. So what we do is we just take all the points and we move the nodes around until we get them to line up, or line up as best we can. Oh, right. And that's what we get them lined up as best they can. And that's where we stop. Now, some of you may be thinking, wait, isn't this a little bit like shooting the bullets and then painting the bullseye around it? But no, it's actually not that, because the plotted points are what are mathematically determined. And then what we're doing is we're moving the nodes around so that they match where the plotted points are. It's the plotted points that drive the nodes, not the other way around. It's not the bullseye that drives where the shots are, it's the shots that drive where the bullseye is. I should say, by the way, that some of you may be looking at this and saying, well, how are there points that are outside of the triangle that those three codes make? And you'll see that sometimes on ENA. And the reason is that the centroids are actually in here. What ENA does, and you can turn this feature off, but what ENA does is it pushes them out so you can see them better. They're still coordinated, it's just everything's been multiplied to make it more visible. Okay, so this finally brings us to the dimensions of the space. We said where stuff is matters. Why? Well, because the plotted points and the centroids line up, right? So if the plotted points are here, plotted points are here, the plotted points are here, these things are aligned. And what that means is that we can interpret the dimensions in terms of the plotted points. So for example, right, the point in the upper left has more self and knowledge than it does interest. And the point on the right has more connections to interest than it does to self and knowledge. If the point is higher up, it has more self than knowledge and interest. And if it's lower down, it has more knowledge than interest and self. In other words, a point to the up and left has lots of self and more knowledge than interest. And something on the right has lots of interest and a little more knowledge than self. In other words, the network graph tells us what kinds of connections points on the right or left or up or down have in common. Of course, just saying I have lots of self and more knowledge and interest is not necessarily that revealing. So somebody who understands the data has to tell us like what the meaning of that is versus the things that are on the other side. But that's where the interpretation comes from. And the magical goodness of fit that Amanda was talking about is literally, right, it's the issue that some of these points are going to overlap really nicely and some of them won't. And the goodness of fit is really just the correlation, right, between the plotted points and the centroids. And what it tells us is how well the network graphs describe the points. That is, to what extent is the fact that something's on the left because it actually has more connections on the left. So, you know, goodness of fit, anything over 90 and you're probably fine. Anything over 80 and you're probably still okay. You know, people use lower ones, but what's happening is your certainty that the location of the point is meaningful starts to dip as the correlation goes down. Okay, so now some of you are saying, well, that's very nice, David, but how do you actually get the node positions there? Because presumably Amanda isn't sitting, there's not like a little Amanda in the machine moving all the nodes around and recalculating all the centroids. And well, there was originally, but then Amanda got tired of it. So we had to come up with a different method. So how do we position the nodes? Well, let's go back to these original matrices. So what we're going to do for these matrices is instead of thinking about them as vectors, we're going to leave them as a matrix. And what we're going to compute is the weight of each node. And the weight of each node is just literally the sum of everything in one row of the matrix. So we can compute all the node weights. And then we're going to find the average. We're going to normalize those. We're going to divide by the number of nodes. And then, right, we're going to say that the centroids, that is the X values for player one, right, are going to be defined by that unit's node weights. So remember the node weights here, I use the omega for. So omega player one knowledge is 1. Omega player one interest is 1. So I'm going to say the centroids on the left, that X, are going to be defined by where player one's knowledge is and where player's one interest is, what the value of those is. And the centroid is going to be each of those values. Those are the weights for that player, right? We're going to sum those up. Sorry, it's going to be an average. And it's an average of the X position of the knowledge node plus times the weight for that player of knowledge plus the X position of the interest node times player one's weight for interest, and so on. We sum those all up and we take the average, and we're going to get the X position of the centroid for player one. So similarly for Y. So all this is, as those of you who know your math, it's just a regression, right? It's just a regression where beta X knowledge times the weight of for player P of knowledge is blah, 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 blah. It's literally just a regression. And so it's a regression where the independent variables are the weights of the nodes for each person. The dependent variables are the X and Y coordinates of the plotted point for that person. And the betas are just the X and Y coordinates of the nodes. There we do 2 separate regressions. And that's the whole thing. Notice that because the independent variables are the weights of the nodes and the dependent variables are the weights of the plotted points, you have to have more unique nonlinear plotted points than nodes, or your model is overfit. Basically, you have more variables in your regression than you have data points to predict them. And what that means is you can't trust the interpretation because the results of the regression aren't unique. Okay, so this was just a quick look under the hood of ENA. What we did was we took these moving windows, we accumulated them into vectors for each player. We normalized those vectors. We did some kind of dimensional reduction, which is just a matrix multiplication, to produce a set of plotted points. Then we did a regression, and that's how we got the plotted points to line up with the network graphs. So that's the math behind how the dimensional reduction works. I'm going to stop sharing and then be happy we can chat about that and anything else people want to chat about. All right, so that. All right. So that's a little fast, but it was recorded. Michael, I see you have a question. Oh, thank you, Hanno. I always appreciate a little applause.
Yeah, that was
Michael. Go ahead.
That was just fantastic. That was really wonderful. So, and it kind of answers a question that I couldn't get answered this morning, which is, so we don't even interpret the X and the Y axis then. I mean, they don't really have an interpretable meaning unless you can think in 6-dimensional space or something like that.
Well, I mean, yes and no. The way I think about it, things that let's just focus on the x-axis, because I even have trouble with 2 dimensions, much less 1. So let's just listen to the x-axis, right? Points either have a low x value, which means they're on the left, or a high x value, which means they're on the right. The point, because of this co-registration, the points that have a low x value are going to tend to have connections to the nodes that are on the left-hand side. The points that have a high x value are going to tend to have connections to the nodes on the right-hand side. If there's some meaningful interpretation of what it means that some nodes are on the left and some nodes are on the right, they're at opposite sides, they're grouped together, whatever it is, right? It's, you know, we think more about collaboration or we think about problem solving. We think more about our self and our interests, or we think more about the mechanics of the space, and in Amanda's case. And so we're basically imposing an interpretation on the x-axis. And for anybody who's done principal components analysis or factor analysis or those kinds of things, it's exactly the same thing, right? You have a set of loadings and you're interpreting the loadings. In this case, the loadings are actually the connections between the nodes. And so if we plotted all the connections and we said, here's the self-cross interest axis, and here's the self-cross organization axis, and here's the organization, like you wouldn't be able to track it. So the network is just a way of representing that more complex set of loadings in a way that's more easily interpreted. So Lupita, did I in fact answer your question along the way there, or do you want to follow up?
Yeah, no, that was fantastic. Thank you. And so I was just wondering if I guess Michael's question is related as well. Is there an interpretation, or not necessarily, of the X and the Y axes and the amount of variance that they help explain in the new space?
Yeah, so if you've done a singular value decomposition, and by the way, I should say you could do any rotation you want, and there are people who played around with those, but if you do a singular value decomposition, what it's going to tell you is what dimension in the space explains the most variance in the data that I have. And maybe that will be a useful thing to know, and depending on where the nodes are, you might be able to interpret some meaning as to why some of the points are on one side of that dimension, some points are on another. That SVD is not a bad solution if you have a few different groups that you want to compare. Basically you could do linear discriminant analysis, which will also maximally separate groups. And so you can see sort of the biggest differences between groups. It turns out it's pretty close to SVD in most cases anyway. But so that's sort of what that would be good for. Like, oh, well, these two groups are similar and this group is different. What's different about that group? Oh, well, it's the nodes it's the connections that are on that part of the space. The means rotation is useful if you have two groups, obviously. And what it does is it says, look, the difference between the means in those two groups is on the x-axis. There are certain circumstances where the nodes won't actually be on the x-axis, but they'll always be, the means, I mean, won't be, but they'll always be parallel to that. And so that tells you, okay, so now these two groups are different, left versus right. What accounts for the difference? Well, whatever the nodes are on the left and the nodes are on the right can account for the difference. Whether that difference is meaningful or useful, that depends on the data, but that's how the interpretation is driven. And what I've found is that if you're going to statistically compare the groups, that if you're actually going to run the statistics, you can do it in two ways. You can think about that in two ways. One is just to say the groups are different, and then say whatever you want about the difference. The other thing, which I think is more powerful, is to give the x-axis an interpretation, and then you're testing for the difference along that now meaningful dimension. This is why, for those of you who have read the QE book, I made a number of mistakes there. The biggest mistake that I made was suggesting that there isn't actually any specific order in which you should present QE findings. And I think that's actually not true. I think that you should always start with the qualitative example, right? Because the qualitative example defines for your reader, and for you, but for your reader, what it is that you actually care about. The next thing you would want to do is present the network graphs, because the network graphs are presumably illustrating the fact that the examples that you showed, when you look at either individuals or you look at the groups as a whole, actually are different in the way that we just saw. And that lets you interpret the axes. And then the third thing you would want to do is present the plotted points and say, and look, along this axis, which I just defined using these network graphs, which reflect what the qualitative finding was, the difference is significant. If you start the other way around, first of all, it feels very ad hoc, but also it's just really confusing for a reader. It also happens to be the order in which you should actually do the things, but that's a logic and use question. I'm going to just, in terms of how you present it, right? That's the way you want to think about it. Is that helpful, Lupita? And yes, Hanal, it probably is time for a second edition, but but for those who are curious, by the way, I think there's supposed to be a Chinese edition coming out in 2022. So that should be interesting. Other questions or comments or things that people want to riff on? Amanda, you've seen this before, so if there's things that you think should be explained in more depth, please feel free to jump in.
I learn something new every time we do this workshop, I will say.
Hello, David. This is Xiaodan here. Yeah,
Hi,
thank
Xiaodan.
you.
Nice to see you.
Yeah, nice to see you too. So, thank you for showing us the math underlying the ENA model one more time. And but I have a question that related to the math but more like practical questions. For example, I have a simplified example here. So, for example, the data, the qualitative data I want to use is from interviews. And during these interviews, there are interviewee and also interviewers. So my focus would be on the interviewees. And when I analyze the data, I found that the interviewers sometimes will repeat what the interviewee said and then provide a follow-up questions. So when we analyze the data, if I exclude the interviewer as, if I exclude the interviewer from the ENA model, but however, there are still connections between the interviewee and the interviewer's word, will that connection still be counted in the interviewee's analysis?
Yeah, that's a great question. I had to think about it for a minute as you were asking it. It does. I believe it does. So what excluding is, all that excluding is doing is it's pulling the data point out of the model. So the exclusion doesn't change how the model is constructed. If you wanted to exclude their lines of data from the model, that would be something you would do with the conversations. Right? So the conversations would define the interviewer's points as out of scope, or you just like remove them from the data. That would be other thing you could do. But exclusion just lets the model run, but then doesn't plot the points. And some of you may have noticed, by the way, that you can exclude points and you can hide them. If you hide, the difference is, now that we've actually explained all this, the difference is if you hide them, you just don't see them. If you exclude them, then they're not used to make the rotation. So they don't influence the way the data is projected, and obviously they're not part of the groups for the means. Right? So hiding is literally just like you're just whiting out the point. Excluding them actually takes them out of the model and lets you look at the points that are not excluded. What it doesn't do is take them out of it. So ENA actually does a number of steps. Those of you who have ever seen or used ENA know this, right? There's an accumulation, then there's a model construction, then there's a plot. So exclusion doesn't stop the accumulation, doesn't change the way that those matrices are counted up. That's the accumulation part. The conversations would shut line out of that, and then the exclusion takes them out of the construction of the model, the rotation, the finding of means, those sorts of things. And then all that show and hide does is literally take them out of the plot, which doesn't really change anything.
Yeah, thank you. That's very helpful. This is confusing me for a while. Yeah.
Okay. Yep. No, that's what we're here for. I see a couple of questions here, or at least one. So in write-ups, do you ever show the relative frequency of co-occurrences or the weights of edges in the results? People do both. Jacob, I see your question too. I'll get to that next. I've seen people do both. So first of all, yes, I think it's a very good thing to do, especially if you're trying to be really specific about what the difference in weights are. I've certainly seen people use the differences in weights in other calculations. The question as to whether you use the raw counts of co-occurrences or the weights of the edges is a little trickier, I think. And it depends on what it is that you're measuring and how you're making your claim. So remember, the edge weights that you see if you like hover over an edge in ENA, in the ENA WebKit, or yeah, all right, let's leave it at that. So those are just normalized. right? And all that normalized means is I'm not asking how much you connected A and B. I'm asking how much you connected A and B relative to how much you connected C and D and A and D and A and B and C, all the other things. But again, you can think of it as just factoring out how talkative somebody is. So if that's what you're meaning to represent, then you should use the normalized weights. The problem is the normalized weights don't make as much sense as if you just say, this person had made this many connections and this person made that many connections. And that's okay to do. It's just remember that you can get funny results out of the networks because of that crossover that I showed you, right? When you normalize, you could change the relative weighting of two things. So unfortunately, there's not a unique answer as to what the best way to do that is. When I teach qualitative methods, I always say there's the same answer to every question in qualitative methods, which is it depends. And so in quantitative ethnography, I'm afraid sometimes that's the answer too, and this is one of those cases. Is that helpful? The person who asked the question?
Yeah. Yeah, that was
good.
helpful. Thank you.
Okay. So Jacob, you had a question.
Yeah, thank you for taking this question, and it's always a pleasure to hear David and Amanda speak, and it's nice to see you again, Yuanru. This is a question I posted to Yuanru through email maybe a few weeks ago, and it's something that's kind of turning around in my mind for a while. I'm really curious about like this idea, you know, the connections between codes, the connections between discursive elements, and what's really meant by something having a connection between it. It seems to me that it's often we interpret ENA graphs as having a stronger or weaker connection. But I'm concerned that the basis for saying that a connection is strong or weak is made by frequency of co-occurrences within the stanza. And I don't know if that's a fair way of making the claim that connections are strong or weak, particularly when like some type of qualitative interaction could have like really structured the conversation occurring later on. So I'm curious if you could help me kind of think through like how to make sense of connections between codes, and is it really fair to put codes on this kind of this numerical line, whether they're strong or weak, and how else to think about codes, connections between codes.
Man, do you want to crack at that one? You're muted.
Sorry, I was answering Angie's question. I'm happy to tackle it, but you might have to rephrase it for me. I'm so sorry.
I can rephrase it. So Jacob was asking about whether or not it's fair to say that two codes are more strongly connected because they co-occur in more stanzas together. And what would be the sort of, what sense would we make of it, and how should we think about the relationship between co-occurrence and strength? Should we even talk about strength?
Right.
Jacob, is that a fair summary?
Yeah, I think that's a great recap. Yeah.
I mean, I think for my data at any rate, it that the way that you're structuring the way you're identifying the moving stanza window and you're using the moving stanza window has to serve you in terms of how you're positioning your understanding theoretically and of the data. So, you know, someone making a connection to interest 3 lines before, and then someone making a connection to knowledge 3 lines after, the fact that they're talking about their interest 3 posts ago, and that they're talking about their knowledge now, and that being connected as a co-occurrence has to mean something for you in terms of your understanding of someone, for in my case, someone's reflections on the self. So for me, that connection is important, because it is important to look at when they're talking about one, and then longitudinally, then starting to talk about another. So in some cases, you know, that moving stanza might be narrower, that connection might be tighter, or it might be wider, or you might not be using a moving stanza window at all. And so that co-occurrence could be valuable to you in different ways, or not at all, in which case maybe an epistemic network isn't the way to go. But I tend to use the strength of co-occurrence across codes. I think David mentioned it. Only in comparison to the weights of other codes in a model. So, you know, it's important for me in terms of understanding someone's process that they are more likely to talk about their interests and in relation to, in these different ways that we've identified, their knowledge. Like that says something to me about how this person exists and is reflecting about themselves. and that it's different than someone who is either not reflecting on them in the same line or is not reflecting on them in time relation to each other. So that's important for me to know, and it says something about the individuals that I'm studying. But I would only ever use that as, this connection based on the value that is in the model is stronger between these two constructs than it is between these two constructs. The numbers themselves are, I don't report other than to do comparatively. Does that kind of answer your question?
Yes. Yes, I think it does answer my question. I guess as I've dabbled in ENA in the past, I've always had this fear that when we're using a movie stanza window to track co-occurrences of discursive elements, what we're really tracking is multiple types of connections, like different qualities of connections. Mm-hmm. And so I'm afraid that there's a kind of flattening that happens when we take these really rich connections that are happening within a stanza and putting it into a numerical value within a matrix. And so I'm sometimes concerned that I'm losing the rich types of quality connections that are actually occurring when it gets transferred into like a matrix. But this is helpful, Amanda.
Well, it's a good point. For one thing, I think that your original question raises something that's really worth highlighting, which is there's no point in using an ENA model unless you have some hypothesis that the relationship between discursive elements is what you care about. Right? You shouldn't be in ENA if you're not. That's not what you measure. Right? ENA is based on a particular theory of discourse, which means a theory of how people make meaning, which is that meaning occurs in the relationships between things, not merely in the assertion of things. So that having been said, you're right. First of all, any model flattens, right? Your codes themselves are a flattening, right, of the data. That's in fact the data is a flattening of the original experience. So it's flattening all the way down, as we could say. The question, right, is whether or not we're flattening out stuff that we care about. And my way of thinking about the question that you just raised, that is whether the quality or type of connection matters, would be to say that implies to me that that you have a code that you haven't identified, or codes, right? That there's some feature of the discourse that you care about that you haven't given the model. So of course it's flattened it out. Now we're talking in the abstract, so I don't know exactly what that feature would be, right? But if you're going to tell me there's codes A and B, and there's connection type 1 and connection type 2, right? The very next thing I'm going to say to you is, how do you know it's connection type 1? And in order to answer the question of how it's connection type 1, you're going to have to point at something in the data. And that act of pointing at the data is identifying the code, right? Whether or not you explicitly call it that, right? Because there has to be some evidence. And so again, that's not a full answer to the question, but that's the way I think about that concern about flattening, right? If we're concerned about flattening, it means that there's something in the model we haven't encoded and taken into account throughout in our segmentation and whatever else it is. But is that helpful, Jacob?
That is very helpful, yeah. And I think I was also thinking along those same lines, that the flattening, if I'm concerned about a flattening, then I'm concerned that my model isn't catching everything that it should have been catching. So that's a helpful line of thinking for sure. Thanks.
Yeah, this is one of the generic challenges that we have as people who care about both ethnography and quantitative modeling, right? It's very tempting to say, well, the model is too simplistic, right? How could the computer didn't catch this? I'm like, well, it's not going to catch it if you don't. The model won't capture it if we don't actually find some way of encoding it that the model can work with. You have to be a little bit careful because there are some kinds of things that are very difficult to encode, sarcasm being one of them. Sexual innuendo, it turns out, is another. But so the fact that in principle you could identify it doesn't necessarily mean that it's always so easy, but that's always, in a sense, what's going on, as you say, when you're concerned about flattening.
Right. I think if you're intentional about the decisions you are making about how the model is created and how that connects to your understanding of the processes you're assessing and the data, then what you get out of an epistemic network or any network is in this case, it's revealing of certain patterns within the parameters that you have set. But I personally I've never come across a model that answers every question or covers every nuance of everything I'm asking. It's always a lens with which to understand a facet of the data. And as long as anyone, I think, is positioning themselves within that frame that they set, then that can be of use to them. But it is not going to cover every facet of your data, which is why I always bring it back to the qualitative to help fill in those gaps.
Yeah, Adam Lefstein, who was on the call earlier here and had to leave because he's in Israel, and I think it's like 3 in the morning there or something. But once pointed out to me that that there's I think it's a Borges story about a country that was very concerned about keeping track of its population. So they constructed a map that was at a 1-to-1 scale. That is, it was as big as the country itself. And that such a map isn't really very useful because it doesn't actually compress the data, right? So all models are like that. It doesn't actually help us unless we leave stuff out. The question is always, are we leaving the right stuff out? And that's why we use multiple models, because they leave different things out.
That was a great question, though.
Well, this notion of taking co-occurrence as a proxy for connection is also, right, is also an assumption. And there's a bunch of assumptions that are encoded in that. I know this because Yehu has been trying to disentangle the different assumptions that go into connection making. And it turns out that it can be a little bit messy. Yehu, I won't put you on the spot because I know you're in the middle of writing about this stuff, but do you want to say anything about that entanglement?
Sure. Yeah, I can talk a little bit, and maybe somebody here in the room could help me out. So I think there are 2 ways to think about the connection strings or the connection, the relationship between different codes. The first one is we consider the reason temporal context, which is the approximation of the common ground of the current utterance. And that's also the way that QE book or any previous paper about ENA is talking about. And we were thinking about, so that's one way to operationalize it. But it also, as we discussed just now, it's approximation. It actually accounts, for example, it's fair, it accounts for 97 different data across the data set, but it sometimes overestimates the connections within the moving standard window. So we were thinking about a new way of kind of like modeling the reason temporal context, which is to use the probability model to think about if we locate a certain utterance in the discourse, and what is the probability of its getting referring back into the previous data, or if we want to know this current line, like we need to know some previous line and what's the probability of that. So we were thinking about making this probability model to approximate the connection strengths by using this probability. So those are 2 different ways to think about it, and they are rooted in different kind of theory of discourse. So yeah, I would be curious about how you think about this, Jacob.
Well, thank you, Yehu. That stuff is always challenging to disentangle. One of the challenges, of course, is that people have a very difficult time thinking in terms of fractions. So what does it mean to say that these 2 things are connected, but only at half the strength of those other 2 things? This sort of goes back to your point, Jacob, right? Or the probability is 50% that they're connected, so we're going to use it in the model this way. When you go back and look at the qualitative data, it's very hard to make sense of it that way. So there's there are challenges that we can handle mathematically, but then they introduce other interpretive problems. Well, it's late even where I am, or getting late even where I am on a Sunday. So, Sung, do we have a chat, a sort of the coffee time after this session? I saw something go by in the chat. So why don't we do this? Why don't we wrap up the part of the session that's been recorded, and I won't be having coffee. I'll be having something more tasty than that. But I'm happy to join anybody who wants to continue the conversation in the coffee room. I assume Amanda will as well.
Yes, absolutely.
But yeah, but I just want to thank everybody for a great discussion. It's always fun to unpack assumptions that I haven't necessarily thought about in a while. And Amanda, thank you so much for a great presentation as well.
Oh, thanks. And thank you as well. I learn every time you share this. So it's always a joy to talk to everyone and have these questions get raised in a forum like this.
Super. Well, have a great conference, everybody. And I'll see some of you in the coffee clutch next. Bye-bye.